All right, hey Kylie. So a little bit of a trig intro. Okay, so this will probably be just enough to make it confusing, or just enough to make you dangerous. Not sure. All right, so these are your three main trig functions: sine, cosine, and tangent. And so this definition is going to relate to right triangles. All right. So you can define the trig ratios, you can define the trig functions as a ratio. So what I need to do here, this is read as sine of x, where x is going to be like an angle. So I need to put an x here in this triangle just to kind of define this stuff. I could either be looking at this triangle from this perspective or from this perspective. All right, so I'm just going to choose this one kind of at random. All right, so if this is my x, my angle, then the side opposite x would be this one right here, right? Opposite. And the hypotenuse is obviously the longest side in the right triangle, all right? Hypotenuse. And so from this perspective, this would be the side of the triangle that is adjacent to the angle x. All right, adjacent. So adjacent just means connected, and you obviously know what opposite means. So whenever I say sine of x, I'm talking about the ratio or the division of the opposite over the hypotenuse. So it's always going to be the same ratio. Okay. Cosine would be talking about whatever this length is divided by that length, and then tangent of x would be opposite over adjacent. So just knowing these three right here, sine, cosine, tangent, that usually goes a long way as far as the ACT goes. I'll give you an example down below, but uh, so like I guess the acronym or the way that a lot of people remember it is SOHCAHTOA. SOHCAHTOA. So sine is opposite over adjacent, cosine is adjacent over opposite, and then tangent is opposite over adjacent. So that's a little mnemonic device that a lot of people use for remembering these. So let's give an example here. All right, so I've got this random right triangle here, and I'm just going to do a triangle that I know exists. I'm going to look at a 5, 12, 13 triangle, and I'll label this angle up here. I'll label this x. Okay, so if the question might say, hey, can you tell me what the sine of x is? Like that might be the question. And all you have to tell them is, from x's perspective, you just have to state the opposite side over the hypotenuse. So it would be opposite would be 12 and the hypotenuse would be 13. So sine of x would simply be 12 over 13. Okay. Cosine. Cosine would be adjacent over hypotenuse. So from here, the adjacent side would be 5. So cosine would be 5 over 13. And then tangent of x would be opposite over adjacent. So it'd be 12 over 5. All right, and that a lot of times there's questions like that where that's a pretty simple example, but sometimes those will pop up where they give you all the information. It could have been that they just gave you the 5 and the 12, and they could have asked the same question. Well, if they didn't give you the 13, you could figure it out real quick just using the Pythagorean theorem. A squared plus b squared equals c squared. Another thing that might pop up, another thing that they might ask here is you might have to actually apply one of these trig functions to solve for part of a triangle. All right, so in this one, they're giving us a 20-degree angle, and I guess we know this is 70 as well. We get that for free. But they give you one side length, but not the other, so you can't use Pythagoras. You actually have to use one of those trig functions. All right, so from the 20-degree angle, 6 would be the opposite side, and you're solving for the hypotenuse. So since you're relating the opposite and the hypotenuse, that tells us we got to use sine. That's going to be our function that helps us solve this question. So what the equation I'm going to set up is going to be sine of 20 degrees, and that's going to equal 6 divided by the hypotenuse, 6 over h. So if I just algebraically manipulate this a little bit, I'm going to multiply through by h. I'd like to multiply by h. There it goes. Multiply by h. So my h's cancel. I get h sine of 20 is equal to 6. And then I would divide by sine of 20. So divide by sine of 20. Okay. And so I would get h is equal to 6 divided by the sine of 20. Now, on the ACT and stuff, this is usually how you will see the answer. All right, they won't actually work out what this is. I'll show you how to work out, like, as a number, as a decimal, what this is. But a lot of times, this is what you'll see. That'll be the way that they have their answer. Another way that you could have solved this one, since you knew that this was 70 degrees, you could have said cosine of 70. Remember, cosine is adjacent over hypotenuse. So you could have said cosine of 70 is equal to 6 over h, and then you would have done the exact same steps. You would have gotten h is equal to 6 over cosine of 70. But if you want to figure out what number this is, like an actual length for what that is, so you take your calculator, which, by the way, if you need to come grab one for the ACT, come do it. On your mode, you need to make sure that you are in degree mode. Most of the time, these things are in radian mode to start out with. So you would need to make sure you're in degree mode. Now you can literally divide it out. 6 divided by the sine of 20. Okay, it assumes that you're talking about degrees, so you don't have to put a degree symbol there. And that's going to give you 17.54. Awesome. Cool. So there's that. Let me find another one here. Okay, so this is from a little practice test. It says if tangent is equal to 3/4 tangent of x, what is the value of cosine x plus sine of x? This is probably a kind of a tricky question, actually, but I'll show you. All it does is it has to do with building your own triangle. All right, so start off, tangent of x is equal to 3/4. So what I'm going to do is I'm going to build a triangle so that this is true. All right, so I'm just going to start with a random right triangle here, and I'm going to label either one of these as my x. All right, I'll label that. So remember, tangent, that one is equal to opposite over adjacent. So the opposite from x would be a 3. All right, that's the idea, opposite over adjacent. And that would be a 4. Obviously, I drew this kind of backwards. I mean, you could roll with it. I'm just going to scribble this out and pretend I chose this to be x. Oh, wait, no, that would be wrong now, wouldn't it? Dang it. Oh, I got it. I'll leave my x here, and I'll change this to a 3. There we go. Now it looks better. It looks like the dimensions line up more. So tangent of x is equal to 3 over 4, opposite over adjacent. In order to find sine or cosine, you have to know the hypotenuse. So because you've got two sides, you could use Pythagorean theorem, or if you happen to remember, this is a 3, 4, 5 triangle. All right, it happens to be one of those Pythagorean triples. So you could solve for this side using Pythagorean theorem. Well, now we can actually answer the question. The question was, what's sine of x plus cosine of x? So sine of x would be 3/5. Right, it'd be opposite over hypotenuse. And then cosine, that's going to be adjacent over hypotenuse. That's 4/5. And then you add these up, and you get 7/5. That was one of those answer options right there, 7/5. Oh, There sure is a whole lot more. I'll see if I can find some practice questions maybe to throw at you, but there is a lot to trig, a whole bunch. Another thing, what's another random fact that kind of shows up? This right here, sine squared plus cosine squared is equal to 1. This is just this is called a Pythagorean identity. And this is always true. They they kind of slip questions in that have something to do with this all the time. And if you don't know that sine squared plus cosine squared automatically equals 1, you'll overlook it. So it's a real simple identity, honestly, real common one. So you got sine, cosine, and tangent. So these are the main ones. I don't know if they're going to ask about the other ones. Okay, and tangent's opposite over adjacent. The other ones, they're not so common, but they're called the reciprocal trig functions. And those are cosecant, secant, and cotangent. All right, sine and cosecant are reciprocals of each other. I know it's kind of backwards from the names. You would think that cosecant and cosine would be related, but it's not. Sine and cosecant are reciprocals of each other. So instead of it being opposite over hypotenuse, it's hypotenuse over opposite. So like if they tell you in the problem, like they might say, hey, sine of x is equal to 1/2, and they expect you to know what cosecant is. Well, oh gosh, cosecant of x would just be the reciprocal, so it would be 2. All right, and then secant would be the same idea, hypotenuse over adjacent. And then cotangent would be adjacent over opposite. All right, those are called the reciprocal trig functions, these three, cosecant, secant, and cotangent. Probably good. If you have questions, like definitely ask them. I'll see if I can help you.